going to talk about the condensation, the polymerization. So there are two types of polymerization. The first type is the addition polymerization, and it involves alkene, and we need a radicals under UV condition and photosensitizer, and a photosensitizer is used to absorb the UV light and transform it to the energy and being used by the alkenes. So the general equation would be the alkene. So the general equation say we have an alkene. We have lots of alkene and it can form the alkane bond. So the alkene bond eventually it will break. So it will have n monomers to n repeating units, also known as the monomers, joined together through chemical reaction to form a long chain macromolecules known as the polymers. So how does the reaction works? The mechanism consists of 3 steps. The first step would be the initiation. So we need to generate we need to generate a lot of radicals. So normally we would use peroxide. So ROOR, undergo UV and photosensitizer, and it will form 2 radicals. So it will break the molecules. So one goes here and another goes here. Note that the arrow is half arrow, meaning that these electrons, only one electron go to the corresponding carbon. So the second step would be propagation. So in this particular process, the radicals will react with the alkenes. So the pi bond is going to break. It's a weak bond, so it will break the bond and react with these electrons to form a new bond. And don't remember that one bond consists of 2 electrons, so the other electrons will go to the another carbon to form a new radicals. So these radicals can react again with the monomers. So that's how the propagation goes on, and it does not end unless the monomers is being used up. So when the monomers is being used up, we reach our final step, which is the termination. So in this specific process, the radicals, say with these radicals, 2 moles of this radical will join together to form a new macromolecules. So this is a non-radicals. So in short, in the first process, we'll generate radicals, okay, through UV light and photosensitizer. In the second process, so the first process is known as the initiation, and second process is propagation. In this particular process, one radicals, so radicals A will react with non-radicals, which is our monomers, to form a new radicals, so radicals B. And radicals B can react again with non-radicals A, and non-radicals A, also known as the monomers, can react with the radicals A as well. So that's how the continuously reaction occurs. So once the monomer is being used up, termination occurs. So in termination, the radicals, so say radicals A and radicals B, they will form non-radicals. So that's how it works. So now let's move on to condensation polymerization. So this is particularly more easier than addition polymerization, and we just look at the reaction mechanism because there's no catalyst or reagent needed normally, but in industrial we often use acid to speed up the reaction. So in condensation polymerization, there could be 2 possible reagents. The first one is between the amino acid. So this is the amino acid. So when we have another amino acid, the lone pair from nitrogen will attack the carbonyl center for the carboxylic part of the another amino acid, and the electron goes up. So this nitrogen is partial positive. Now the electron from oxygen will move back and the OH group will leave. But this process is quite slow because OH is not a good leaving group as it is a strong base. So basically we'll need acid to catalyze the reaction. But it's possible to happen, but just very slow. So as a product, Now, one problem remains, which is the nitrogen is positive now. So the OH negative will grab one hydrogen from the nitrogen and electron gives back to form an amide bond and the final product. So usually we will see the water as a side product. So as you can see, one water molecules is generated. Now let's look at the other types of condensation reaction, which often happens between a diamine and dicarboxylic acid. So di means double. The electron from the lone pair from the nitrogen will attack the carbon center of the carboxylic acid part, and the electron goes up, and basically the reaction just reacts the same. This OH molecule is being removed, and it will deprotonate one hydrogen from the amine group and give us the final product. So an amide bond is formed, and these molecules, it can react because as you can see here we have another lone pair. It can attack again the dicarboxylic acid, and that's how the reaction continuously happens until the monomers is being used up to form a long chain of monomers repeating units known as the polymer. So that's the overall reaction mechanism. So in short, in condensation polymerization, it can occur between dicarboxylic acid and diamine, or it can occur within two amino acids because it contains within one molecules of amino acid contains one carboxylic group and one amine group. And as a side product, water is eliminated, and the reaction usually needs heat because heat is being used to eliminate the water, and hence the condensation reaction can take place.